Hello, all my wonderful students. We're going to be kicking off today's lesson, talking about our last topic for our second booklet, the last thing that we have to talk about in the motion section, what we call kinematics in physics, basically just the math of motion, which is what we've been doing this whole time. Our last topic that we want to talk about today is how we graph non-uniform motion, okay? Now, it's a little bit trickier than when we did graphing uniform motion because not all of our graphs are going to end up looking the same. With uniform motion, all of our graphs just have a straight line, right, on a position time graph. On a velocity time graph, they're always a flat horizontal line. There's really not that much difference from one graph to another. But now that we have objects that are in non-uniform motion, that are accelerating, it's going to change what our graphs look like, and they're going to become a little bit more complex. So we need to be able to understand a whole bunch of different things that a graph is telling us. Remember that graphs just tell us the story of how something is moving, and what you guys need to be able to do is interpret from the graph, looking at various parts of the graph, tell me the story of that object. So some of the things you need to be able to tell me from a graph, some of which we've already done, is which direction the object is moving in. And we can tell that from its velocity, right? If its velocity is positive, it means it's heading up, or to the right, or to the east, or north. If it's negative, it means it's heading south, or down, or left. Or which one did not say west, okay? So we need to be able to tell which way the object is moving, okay, whether the velocity is positive or negative. We need to know where the object is compared to a reference point, all right? So not only which way is it moving, but where is it compared to the starting spot, or where I'm standing watching it, or whatever your reference point happens to be, okay? And now that we're dealing with non-uniform motion, we need to be able to tell how things are accelerating. And there's two pieces to how something is accelerating. Okay, we have talked about them already, but to bring it back, we need to know if the acceleration is positive or negative. All right, so basically, how is the speed changing? And then from there, we need to tell if the object is either speeding up or slowing down. And hopefully you got out of last week that speeding up and positive acceleration are not necessarily the same thing. I can have positive acceleration that is slowing down. I can have negative acceleration that is speeding up. So you do need to remember those kind of weird qualitative rules that we talked about last week. Right? So now, then the last thing that you need to be able to do, and we didn't have to do this with uniform motion, but it is important for non-uniform motion, we need to be able to translate a position time graph into a velocity time graph. And what I mean by that is if I give you a position time graph, you should be able to draw a rough version of the velocity time graph. Or if I gave you a position time graph on a quiz, and I could say something like which velocity time graph matches this position time graph, all right? So we're going to talk about how we do that today. We're going to talk about the key things to look for as we move through and look at the graph and try and understand what the graph is telling us about how that object is moving. All right, so with graphing accelerated motion, just a couple of reminders from when we graphed uniform motion, because all the rules we talked about when we did uniform motion are still true. Everything that we talked about how to read a graph, it tells us the same bits of information. So just to bring it back kind of quickly, remember that if I'm looking at a position time graph, if I want to know where the object is located compared to the reference point, I just have to look at where it is on the y-axis, right? If it's above the 0, that means it's located to the right or up or whatever my positive direction is. If it's below the x-axis, then it's to the left or down or south or west or one of those negative directions, right? But the important bit, because this is good to know, it's helpful, but where I find that students get really confused is on this point here. Right, so we talked before about how whenever I figure out the slope of the line, what that's telling me is the object's velocity. All right, but I don't necessarily need you to always calculate the slope. I also need you to be able to interpret it kind of qualitatively just by looking at it. So just remember that if an object or if a graph slopes upwards like that, it makes that line there, that means it's got a positive velocity. It's moving to the right. It doesn't matter if it's like that or like this or like this. If it's got a positive slope to it, it is moving up, or it is moving in the positive direction, okay? And then you should hopefully know that the steeper the line is, the faster it moves. So this line here is faster than this one, which is faster than this one, okay? If the line slopes downwards, like this, that means it's got a negative velocity. It's moving left. It is moving south, whatever one it is. And again, the steeper the line is, the faster the object's moving. So in these three lines I just drew, this guy here is going to be my fastest. It's the steepest one, but it's just steep going downwards compared to like this guy here. It's the inverse of this one. This one here is the medium one, and this one here is my slowest. barely even going down, okay? Then, we talked about velocity time graphs back in uniform motion, but we didn't talk that much about them because they're not very interesting with uniform motion. They're always a flat line, and I can just make it be higher or lower than another one. That's it. With our uniform motion, or non-uniform motion, I should say, when our speed starts changing, we're going to get changes in our velocity time graphs, right? I'm not going to have a flat horizontal line anymore because my speed is either increasing or decreasing. So a couple rules to remind you of that we didn't really pay that much attention to back in uniform motion is that, remember, on a velocity time graph, to figure out how quickly it's moving, its velocity, I just need to read where it is on the y-axis. The higher up on the y-axis it is, the faster it's going. Okay, or the further from 0 on the y-axis, the faster it's going. That's a better way of phrasing that. And the slope of a velocity time graph tells us the acceleration. Okay, meaning that just like those other lines, if I have a positive slope on a velocity time graph, that means I have positive acceleration. A negative slope on a velocity time graph tells me I have negative acceleration. So the fact that that line here is going upwards, that tells me that this is positive acceleration. This line's going downwards. That's going to be negative acceleration. All right. We didn't see these back when we did the speed time graphs for the uniform motion, but we're going to start seeing this now. All right. All right, before you watch any further in the video, I want you to take a couple of minutes to graph there's two graphs on page 18. The data is already provided to you, and I'd like you to do is make a line graph for those and just connect the dots with straight lines, right? You're going to want to have that with you while we're doing this. I will show you what the graphs should look like, or should roughly look like, on the next slide, but you should have them for yourself as well, because this is technically a part of the notes. Normally we would do this as a bit of a class conversation. So take a couple minutes here and graph the data on page 18 so that the rest of this you have in front of you and you can actually take a look at it. All right, so once you have those graphs done, the first graph number 1, should end up looking something like what I have up on the screen here, all right? And you should see right away a big difference between a graph showing acceleration compared to the uniform motion graphs we looked at before. The biggest difference is that this line curves, okay? We no longer have a straight line like we saw back in uniform motion. I have a line that is curving. In this case, it's curving upwards. It's not always going to be curving that way. All right, but here's what my graph looks like. And a couple things I want you to note, and there are some questions that go with the graph, but a couple things I want you to note. Number one, remember, you need to be able to tell me where something is compared to a reference point. So looking at this graph here, I can tell that this object is located to the east. It's talking about east in the data table. I can tell it's located to the east because it's above my x-axis. If this curve was like down below here and it was doing something like this, which we'll talk about later, then it means that object's located to the west. Okay, so I know where it is. Second, I can tell which direction it's moving. All of these lines here are sloped upwards. They're all doing this to some degree, which means that this is positive velocity. All right, so because this object has positive velocity, it's heading to the east. So it's located to the east and it's heading east. So it's already bits of information I can get. The third thing I can ask is this object speeding up or slowing down? Okay, and I want you to take a look at this line and how the line changes over time. All right, so just to show you here, in the beginning, my slope here is relatively flat, right? And we know that the flatter the slope is, the slower the object is moving. So I start out kind of slow here. I have a very small, very gradual slope. So I don't even have to do the math here. I can just tell from looking at this line that this here is not moving very fast to start with. Now let's look at this last second. This last line is much steeper than this one. And so what that means is this object is getting faster because my object, or the slope here, is getting steeper and steeper and steeper the entire time this thing is moving. And because the slope is getting steeper, and the slope tells us the velocity, this object is speeding up, it's heading to the east, which I know, and it's located to the east. So I already have my 3 bits of information. The other way that you can tell just that this object is speeding up, if you're not sure, is just look how much distance it covers every second, okay? I'm going to do this part here. If I look at time 1 to 2 seconds, okay, between 1 and 2 seconds, it's only traveled this far as that blue line that I just kind of like traced on there. That's not very far. If I look at the actual numbers, it's only gone 30 meters. When I look at time 4 to 5 seconds here, again, in that same amount of time, in that same 1 second, this object has traveled much further. And so because my line here is taller than this one, it means this object has traveled a greater distance in that second than it did in this second. And I can tell just from my table of values that that's true. Between 4 and 5 seconds, this thing goes about 90 meters. Between 1 and 2 seconds, this thing only goes 30 meters. All right. And then the last thing I can ask you about this thing moving is whether the acceleration is positive or negative. We know it's speeding up, okay? That's going to help us, but it doesn't tell us the whole story, because remember, negative acceleration could be speeding up as well. So what we want to do is take a look to figure out whether it's positive or negative acceleration. There's a couple ways we could do it. We could actually just think through it to start with. So number one, we said that this object is going east, right, because it's sloped upwards, and we said its speed is increasing to the east. We talked about how positive acceleration means that your speed is becoming more positive over time, and because this line becomes steeper in a positive way, it's going up the whole time and getting steeper as it goes up. What that's telling us is that it's increasing its speed to the east, it's increasing its speed in a positive direction, which is positive acceleration. If you're not totally sure on that, then you're going to want to take a look back at the notes that we did last week with all the different types of acceleration. But there's an easy trick to figure out from our graph whether it's in positive or negative acceleration. And that's to look at how the graph curves. And I find that students get a little confused on the idea of curving versus slope. All right? The slope just tells us how steep the line is. The curve can be one of two things. It can be a curve upwards, and a curve upwards looks like this. It looks like a U. I always like to say it looks like a happy face. Okay. A curve downwards looks like a sad face. Okay, it looks like this. All right. And when you look at my graph here, if I asked you, hey, is this line curving up or down? Most of you, before I even drew those, you would have said it's curving upwards. Right? I find most students think that, and it's true. If you look at my little smiley face that I drew, and if I were to carve like a line down the middle of it, you'll notice that the graph that I have here, this curve, matches this half of my smiley face. All right? The trick is, and what's cool about this, is the smiley face is always positive acceleration. If you have a line that looks like this, that's going to be positive acceleration. If you have a line that looks like this, still positive acceleration. So whenever you have a smiley face graph, it's always positive acceleration. A sad face graph is always negative acceleration. All right? If you're not sure why that is, take a look at this guy. If you look at this graph here, imagine that this is something in motion. See how it starts off with a very steep positive line? And then as it gets further and further along, that line becomes less and less and less steep until it becomes essentially flat. And then it becomes more and more and more negative. So the first half of my little sad face here, the first half of it is starting with a really positive velocity and it becoming less and less and less and less positive until it hits 0 right here. So this whole first half of the graph is something that started out really fast to the right, but slowed down. The second half of the graph is something that starts out kind of slow but negative and becomes more and more and more and more and more negative. So the entire time this graph is, this object is moving, its velocity is becoming more and more and more negative the entire time. Same thing's true over here. On this side, I start with a very, very steep negative line, and it becomes less and less and less and less negative as we move through. The line becomes less steep, it becomes more gradual, till eventually it hits 0, and then it becomes more and more and more and more positive. So this entire motion is positive acceleration. This entire motion is negative acceleration. So in your book there on page 18, it says, which direction is this line curving? It's curving up. It's the second half of my smiley face. Okay, and then we already said that this object is speeding up, and that this is positive acceleration because I have a smiley face, and it's becoming more steep in a positive way. Here's graph number 2 on page 18. All right, when you graph that data, you still get a curve. All right, except this time it looks a little bit different. All right, it's still curving. The fact that the line is curving tells us it's accelerated motion. As soon as you see a line curving at all, we're dealing with something that's accelerating. Okay, but this one is behaving a little bit different than the one that we saw before. So again, we're going to talk about what we can find out from our graphs. All right. Number 1, we ask where this object is located. Again, this object is located to the east because it's above my x-axis. So I'm the observer watching it here, and this thing starts out pretty far away from me and gets closer and closer and closer to me as it moves. Okay. We could ask you which direction it's moving, and I can tell which direction it's moving based on the slope of the line. These lines all slope down, And because it's got a negative slope to it, because it's going down, that's telling us that it is moving to the west. So this object started fairly far east of us and is moving towards us. Therefore, it has negative velocity. It is moving to the west. Right? So we already got our 2 bits of information without doing any math whatsoever, just from this graph. Next, we want to figure out whether the object is speeding up or slowing down. To do that, we look to see how the slope changes. If the slope becomes steeper and steeper and steeper, then I have an object speeding up, which is what we saw in the last one. If I have a slope that's getting more and more and more flat over time, then I have an object that's slowing down. Let's just take a look. We're not going to do any math here. We're just going to look at it. Here I start out quite steep. Here I'm not very steep at all. So this object is slowing down because its slope is becoming more and more and more gradual over the entire trip that this is taking. Right? So now we have an object that is slowing down, which we figured out just from looking at how the slope changes. And then the last thing, we want to figure out whether this is positive or negative acceleration. You should actually know the answer based on what we said on the last slide, but if you're not sure, just take a weird look at this guy. We said it's moving in the negative direction, right? Because it's sloping down the entire time, so we know it's moving to the west, and it's slowing down to the west. It is slowing down in a negative direction. That is positive acceleration, which I know seems counterintuitive, but we did talk about this before. If a speed is becoming less and less and less negative, that is positive acceleration. You can think of it that it's becoming more positive over time, okay? And if you think back to the little U now, or the smiley sad face thing, this is also still a smiley face, okay? This time, though, we have that's a really wonky smiley face, but that's okay. Now it's just the first half. Okay, so now it's this half of the curve, starting with a very negative speed and becoming less and less and less and less negative while it slows down. Okay, so that's all the information we can find out from it. There's questions on this graph on page 19. It says, what direction is this line curving? It's curving upwards. Okay, it's still curving up. It's just the first half of my smiley face, whereas the other one was the second half of the smiley face. Okay, is it speeding up or slowing down? It's slowing down. It's becoming flatter. And so when it says, by looking at the slope of a position time graph, how can you tell if it's positive or negative acceleration? If it curves upwards and makes a U face, or a happy face, positive. If it goes downwards and makes a sad face, negative. All right. If you haven't done so already, if you guys go to page 19, it wants you to make graphs, it makes velocity time graphs for the 2 graphs we just looked at. All right, if you're not sure how to come up with the numbers for velocity, you can just use my notes. That's one way to do it, and my notes have the answers on them. But if you're wondering where the numbers come from, which you should wonder, all I do is try and find the speed at each time interval that's indicated to me. So to do that, we just have to do a very basic slope calculation. All right, I'm going to do a couple of these for you. So as an example, I'm going to do the time 1 to 2 seconds. We're going to do a slope calculation here using those 2 points. Right? So the position at 2 seconds is 40 meters. The position at 1 second is 10 meters. Divided by 2 seconds minus 1 second, which gets me when I do that division, I get a speed of 30 meters per second. Okay, you're going to want to do this for each time interval and fill in the data on page 19, and then I'd like you to graph that data and do the same thing for in graph number 4. This time you're going to look at you're going to use the information from graph number 2. All right, if you're not sure where the numbers come from, just take a look at my answer key up on D2L. Okay, so here's our velocity time graph for graph number 1. All right, so this is technically graph number 3. Hopefully that doesn't mess you up too much. We're still on page 19. And what you should get when you graph this object's velocity and how the velocity changes over time is this. All right. In Science 10, when we talk about acceleration, we're always talking about what we call uniform acceleration, where something increases its speed at a consistent rate. And whenever we make a velocity time graph of that, what we get is always a straight line, going upwards or downwards. It does not matter, okay? So in uniform motion, I know an object's in uniform motion if its velocity time graph is horizontal like this. We know an object is in accelerated motion when the line goes up or goes down, okay? But it should still form a straight line, all right? So you should have something that looks like this. The questions in the book say, is this line straight or curved? This is a straight line, All right, we will never get a curved acceleration or a curved velocity time graph, even when we deal with acceleration. All right, is the slope positive or negative? We can just look at it. We don't even need to calculate it here. Just by looking at it, the line goes upwards the whole time. This is positive. It has a positive slope. And remember, the slope tells us the acceleration. It has a positive slope, so this is positive acceleration, which we figured out on that when we talked about this graph in detail. All right. Then it wants us to calculate the slope of this graph to actually come up with the number for it. So as usual, it doesn't change how we do it. We're going to pick any 2 points. In my notes, I picked this one and this one. It does not matter what you chose to do, though. We're going to use the same slope formula we've always used. So this guy here is my x2, y2. So I'm going to go 70 minus 30. 30 coming from here. Okay, divided by 4 seconds minus 2 seconds, okay, which gets me 20 meters per second squared. All right, I should have had my units here. This is meters per second, which is how we get that unit. So this is telling me the acceleration. This thing's speed is increasing by 20 meters per second every second. So what measurement does the slope of the line tell us? It tells us acceleration. All right. And again, one other thing I just want to point out here is we can tell just from this graph that this object is speeding up. All right. The reason I know it's speeding up is that it's getting further and further and further from zero. So its speed started out at 10 meters per second, ended up at 90 meters per second. So this thing's speed is increasing. I can tell that the acceleration is positive, and I can even tell which direction it's moving. This object is moving to the right, or to the east, I should say. And the reason I know that is that my speed is positive the entire time. My line is above the x-axis, which tells me that my speed is positive the whole time. I cannot figure out where the object is located from a velocity time graph. Okay, so from this graph, all I can tell you is what type of acceleration, positive or negative. I can tell you if it's speeding up or slowing down, and I can tell you which way it's moving. All right, I can only get those 3 chunks of information. The location I cannot figure out. The second graph on page 19, if you did it properly, should end up looking like this. But I can understand if you guys may have messed that one up a little bit. You'll notice that the big difference on this graph versus the last one is that I made my x-axis up here. The reason I did that is all of my velocities are negative, so I need to have them below my 0 line here, and I need to go from least negative to most negative, okay? So now I'm putting my x-axis at the top of the graph to be able to show this off. Right? So let's talk about this line too. We're going to talk about all the things that we can tell about how this particular object is moving. Once again, I know that this object, I can't tell where it is, okay, because it doesn't give me position. I can't find that out from this. I can tell which direction it's headed. All of my values here are negatives, okay, which means that my speed is negative. This thing's velocity is negative, meaning it's moving to the west. All right, so because the speeds are down here, because it's below the x-axis, this object is moving left over time. I can tell if it's speeding up or slowing down by whether or not the line gets closer to 0 or further from 0. Here, my line is getting closer and closer and closer to 0 as time goes on, so this object is slowing down. Its speed is approaching being stopped. It would be stopped if it hits 0. Okay, and then we can tell it's positive acceleration because my line is sloped upwards. So this thing is positive acceleration, slowing down, and it's moving left. It is slowing down in the negative direction, which is what makes this positive acceleration. Okay, what I want you guys to notice is that the line on this one is exactly the same as the line on the last graph, on graph 3. The only difference between this one and the graph on the last slide is that this one is below the x-axis, that one was above the x-axis. The only difference between them, it was that idea. And so this guy here is slowing down in the slowing down as it's going on its journey. The other one is speeding up, but the shape of the line is exactly the same between those 2 graphs. Okay, so I'm going to go through, we're going to spend less time on each of these graphs now. I'm going to focus on a very qualitative approach to understanding position time graphs and velocity time graphs and how they relate to acceleration. We're going to go through a whole bunch of different examples, and we'll quickly talk about how to graph each of them so you guys get the hang of how graphs tell the story of what's happening to them. All right, so I've got my little my axes here, and it says an object that is, we want to draw a graph for an object that is left of the reference point, and it's moving to the left, and it's speeding up, all right? I will never ask you to draw a graph for a quiz question, right? But what I can do is give you a graph and ask you to tell me bits of information like this. Like, which way is this object going? Is it speeding up? Is it slowing down? Is this acceleration positive or negative? And you need to be able to figure out which graph matches the description I gave you, right? So we're gonna go through a bunch of how we can do this by talking about how we draw these graphs, right? So this sentence here is giving me all the information I need. And so what we want to do is just figure out what to do with that. All right, so we're going to unpack all the information in this. So number one, the object is to the left of the reference point. What that means is my graph is going to be drawn down here. Okay, it's going to be below the x-axis because where it is on, like whether it's above or below the x-axis tells us whether it's located to the left or to the right. The left is the negative one, so it's going to end up down here. Okay. Next, the object is moving to the left, okay? Moving left tells me the velocity. What that means is I'm going to have a negative velocity, and because it's a position time graph, the slope is the velocity. So the fact that I have a negative velocity means that my line is going to go down like this. Okay, so my line should look like this, and I should put it below the line. And then the last thing is I have to see which way this thing is going to curve, because it's not going to be a straight line because we're talking about acceleration. So this object is either going to curve this way or curve down, okay? And this last clue here tells us what we need. The object is speeding up. What that means is it's going to get steeper and steeper and steeper over time. So what that's going to do is I want a curve that's going to look something like this, okay? So when I graph this, my final graph that I'm going to throw on here is going to look something like this. This thing starts with this, actually I'll draw it first and I'll talk about it. Here's my final graph for this object. And let's talk about how it meets all these characteristics. It's to the left of the reference, perfect, I put it down here, okay? Had it been to the right, I would have put it up here. It's moving left, well that's good because my line slopes downwards the whole time. It has a negative slope the entire time. And it's speeding up because it's getting steeper and steeper and steeper. I start with a kind of negative slope. It's pretty flat though. And over time I get steeper, 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 steeper. So if I gave you this graph, you should be able to tell me all three of these bits of information just from looking at it. The only other thing I could ask, and you should be able to do this as well, is tell me whether it's positive or negative acceleration. And we can tell from the curve of the graph that this one is going to be negative acceleration because it makes the sad face. Right? It's the second half of the sad face here. This perfectly matches my curve. I start with a kind of negative velocity, and I get super negative over time. So it's speeding up in the negative direction. So this is negative acceleration. The only other thing that you need to be able to do is associate the position time graph with a velocity time graph. All right, so I've got a position time graph here, and I'm going to just kind of erase some of my doodles. And I want to now draw the velocity time graph for it. I'm going to use just like a quick kind of, I'm just going to quickly like freehand this one. Okay, so if I were to draw the velocity time graph for this, what I want to do is look at how this thing is changing. Again, we've talked about how it starts off with a kind of negative slope and gets super negative over time. That tells me all I need to know about what this graph is going to look like on a velocity time graph, right? So if I were to draw the velocity time graph for this, I'll do it in blue just so we get the difference. This object is going to start with a really small speed, okay? So its object is going to start, or its speed, I'm going to have start kind of at 0, okay? I'm sorry that I have to kind of draw it on the same graph, kind of limited by the program here. Over time, the slope of this thing becomes super negative. It becomes very, very, very steep in a negative direction, which means that it's moving, the velocity is moving further and further from 0. So my velocity time graph for this is going to look like that. It should be a straight line, but I can't draw straight very well. All right, so that's the idea here. This blue line is the velocity time graph for this yellow line because I start with a kind of negative speed, and then I get super negative by the time I'm done. Okay. All right, I'll try to get a bit faster with these, and please feel free to come to me with questions on this stuff because this is a tricky concept, okay? So now we have an object that is to the left of the reference, just like before, so I'm going to draw it down here, okay? It's moving to the right, which means it's going to slope upwards like this, and it's slowing down, which means it's going to get flatter and flatter and flatter over time. This thing is going to start with a very positive velocity and slow down. It's going to get closer and closer to 0. So I'm going to curve and get flatter over time. All right? So I actually have all the bits of information that I need to know. This object is to the left of the reference, so I'm going to start it down here, to the left of this reference point. It's moving right, so we're going to have our line going upwards, and it's going to get flatter and flatter and flatter over time. Okay? This is now, this graph that I've drawn is the exact position time graph for this thing. It covers all 3 points it's talked about. We could ask then, is it positive or negative acceleration? This has to be negative acceleration because I've got the first half of my sad face. It looks like this line here. Right? It's slowing down in a positive direction, which is a form of negative acceleration. All right? If I were to draw the velocity time graph for this one, I'll do it in blue again. We start off with a very positive speed. It's very steep there. We end up close to 0. So this thing's velocity time graph, so I'm just going to erase some of the things I've drawn just to give myself some space. So my velocity time graph, I just have to have those 2 points in there. This thing starts off with a very positive speed. Okay, so you see how my velocity is up top, and it gets closer and closer to 0 over time, so my line is going to come down like this. I can tell from this that this object has negative acceleration because it's sloping downwards. I can tell it's slowing down because its speed is getting closer to 0. All right, so that blue line, that velocity time graph, matches my position time graph. Okay, next one. So this time we have an object that is to the right of our reference point. This time I'm going to draw it up here. It's moving left, so that means I'm going to have a line sloping downwards the entire time, and it's speeding up, which means it's going to get steeper and steeper and steeper over time, which means it's going to do that. Okay, so now we're just going to take those 3 things, we're going to put them together. This thing starts off to the right, so I'm going to have it start up here. All right, it's moving left, so I'm going to have it, and it's speeding up as it moves left. So it's going to start with a slow speed, and then it's going to curve down and get steeper and steeper and steeper as it gets closer to the reference point. You'll notice that this hits, again, all 3 points. It's to the right of the object, it's above the line, it's moving left because it's sloping downwards the whole time, and it's speeding up because it gets steeper and steeper and steeper and steeper as time goes on. Okay? If I were to draw the velocity time graph for this one, again, all I want to do is really just look at what the line's like at the beginning and at the end. At the beginning here, it's very flat. At the end here, it's super negative. This tells me that I'm going to have my speed, or my velocity, start at 0. This tells me that I'm going to have my speed be super negative by the time we're done, and then all that's left to do is connect those 2 dots with a reasonably straight line. Right? That's all I'm doing when I make that velocity time graph. What is the speed at the beginning? What's the slope like at the end? Plot those 2 points, and then just connect them. It simplifies the process for you. All right, and we can tell here that this is negative acceleration because we're making a sad face, right? We've got the second half of our sad face there. All right, I'm hoping you guys are trying to get the hang of this, which is why I'm going a bit faster. Again, please keep bringing me questions. This is not the easiest stuff. So now we have an object that is to the left of our reference, so we're going to draw it down here. This time it's moving to the right, okay? So it's going to go upwards. It's going to slope up, and it's speeding up, so it's going to get steeper and steeper and steeper to the positive direction over time. Okay, so it starts to the left of the reference, so I'm going to have it start here. It's moving right, and it's going to speed up, so it's going to get steeper, 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 steeper over time until I hit the reference point. Okay, again, my curve perfectly demonstrates those 3 things that I asked. It's to the left of the reference because it's below the line, it's moving right because it slopes upwards, and it's speeding up because it gets steeper. This is a positive acceleration because I got the second half of my smiley face here. All right, so it matches that one really nicely. If I were to make a velocity time graph out of this, again, all I want to do is what is the slope doing at the beginning, what's the slope doing at the end, plot those 2 points on my graph, and then connect them together. All right? At the beginning, I have a very, very gradual, almost flat slope, so it's going to start really close to 0. Okay, so I'm going to plot that point right there. Okay. At the end here, it's very, very, very positive. It's very steep. So I'm going to plot my second point up here, and then I'm just going to connect those 2 things together with a reasonably straight line. I'm pretty proud of that one. All right. So again, all I'm doing when I'm making these is what is the speed at the beginning, what's the speed at the end, Plot those two dots, connect them together. You'll notice I'm not using any numbers because I care more that you understand the story of what's happening rather than get bogged down with math behind it. But we could do the math. We've kind of already practiced it. All right, this is our last graph that we're going to make today. And again, this is not in your notes, but it's something that you do need to be able to do. So now we have an object that's to the right of our reference. We're going to draw it up here. It's moving right, so we're going to have it go this way, but it's slowing down. So it's going to get flatter and flatter and flatter over time. So I'm going to have something that looks like that. All right. So it's to the right of our reference and it's moving right. So I'm going to have it start about here. All right. It's moving right, so it's going to head upwards like this, and over time it's going to flatten off. Okay. So again, I've hit all 3 points. It's to the right of the object because it's above the x-axis. It's moving right because it slopes upwards the whole time, and it's slowing down because the line is getting less and less steep as time goes on. If I were to make the velocity time graph for it, and this one's going to get kind of cluttered up here, I'm going to look to see what it's doing at the beginning. It starts off with a fairly positive speed. So its speed is actually going to start up here. All right, it's got a positive velocity, and it ends pretty flat, which means it's going to end close to 0. So my velocity time graph for this graph is going to look like this guy here, where I have a very positive speed to begin with and a speed near 0 to end with. Okay. This here is just, this line is just tracing the slope and how the slope changes over time. So we can tell just by the fact that we have a sad face here, that this is going to be a negative acceleration. And we can also tell from the fact that our blue line slopes downwards that we have negative acceleration. Okay, so we got through all these examples. It's a lot of information to take in, and it is not the most intuitive thing, especially if you're somebody that does struggle with graphs or kind of struggles with that aspect of science. This can be a confusing topic. So please come to me with questions on Tuesday when we have our online class. But I want to summarize just a few key things here to help you guys out. So in summary, on a position time graph, an object is in accelerated motion if it has a curved line. As soon as you see the line do this, or whatever it happens to be, that thing is speeding up or slowing down. We're no longer talking uniform motion. If the slope is becoming more positive over time, like it's getting steeper and steeper as it goes upwards, then we have positive acceleration. Easiest way to tell it, though, is look to see if it makes a sad or a smiley face or a sad face. Smiley face tells you it's positive acceleration. It's curving upwards. If the slope is becoming more negative, if we have a sad face, it's negative acceleration. All right. And if the line gets steeper, it's speeding up. If the line gets less steep, it's slowing down. So that's how we can. That's all the information I can tell from a position time graph. On a velocity time graph, there are a few other things we can read. If the line has a positive slope to it, if the slope does this guy here, then it's positive acceleration. If it's a negative slope like this one, it's negative acceleration. If our line gets closer and closer to 0 over time, that tells us the object is slowing down. If the object gets further and further from 0, that tells us it's speeding up. All right, and then I can tell based on where the line is, if it's above or below the x-axis, that tells me whether the object is moving to the right or moving to the left. All right, so that's it for today's lesson. We will go over all this stuff in detail in Tuesday's online class. I'm expecting it to be a bit of a longer one. Couple of big things with that. Please try the practice stuff that I'm posting on D2L. It's relatively short because there's only so many things I can ask about graphs. The one sheet in particular that gets you to kind of match the position time graph to a velocity time graph is going to be the most useful thing for you. And please come bring me questions on that stuff on Tuesday. I hope you guys are doing great. I hope your families are all healthy and happy. And I cannot wait for us to see each other in person again, although I have no idea when that's going to be. All right. Hope you guys are doing well. See you when I see you.